Hi everyone, Sami here. Welcome to another lesson in the BGP series. In this one, it is about the configuration of a BGP peering between two routers. We will be discussing the details behind the command line. After this lesson, we will also have our first labs, so let's get started. One important thing to know about BGP is that there are two types of sessions, and what dictates what type of session to use is the autonomous system number of the peers. When we have two peers from different autonomous systems, it is an external BGP session, referred to as eBGP. And when the peers are from the same autonomous system, it is an internal BGP session, referred to as iBGP. The behavior of BGP changes radically depending on the session type. For now, we will ignore internal BGP and work exclusively with external BGP. This means that all our BGP peering sessions will be between different autonomous systems. Once we get familiar with external BGP, we will talk about internal BGP in an upcoming lesson. Let's start with a little bit of configuration. The basic BGP configuration is really simple. For now, all we want to do is to bring up the BGP peering sessions. You start the configuration by creating the BGP process with your autonomous system number. Let's jump into our router and just do that. Here we configure the BGP process. Let's give it an autonomous system number of 1. Here it is, we are inside the BGP configuration. If we try to create another BGP process, for example, the autonomous system number 2, we will get denied. In a router, you can have only a single instance of the BGP process running. With internal gateway protocols or IGPs, you usually just enable an interface and the process will automatically discover and form adjacencies with other routers that are on the same data link. BGP has also some dynamical discovery mechanisms. As far as I know, Cisco allows you to listen on a range of IP addresses and accept incoming BGP sessions from those addresses. If you look at Juniper, they have an auto-discovery feature where they allow you to enable BGP on an interface just like IGPs do. There is also a new draft in the IETF about enabling BGP to automatically discover neighbors that are on the same data link. As you can see, the draft is pretty recent. So it will allow you to discover neighbors automatically that are directly connected, and it will also allow you to peer on the loopback addresses. BGP has been the exterior gateway protocol in use for many decades now. So why did it take so long to get the auto-discovery feature? The reason for this is that the auto-discovery on the same data link is not a popular demand. After this slide, you will understand why. All IGPs to form a neighbor adjacency require the routers to be on the same subnet. That's why it made sense to have the auto-discovery feature. BGP, on the other hand, allows you to peer to routers with interfaces that are not on the same subnet. It is very popular to peer on loopbacks because physical interfaces might sometimes go down. BGP sessions are often made between peers that are multiple hops away from each other. This is especially the case with internal BGP. When the peers are multi-hops away, or they are not peering on the interface they are directly connected with, it makes no sense to have a data link auto-discovery, because they are not peering on the same data link. The new IETF draft that allows the auto-discovery of directly connected neighbors and to peer on their loopbacks could be useful in that case. For now, we won't be using any dynamical discovery feature and we will specify each BGP peer explicitly. Let's get back to the configuration. Once we are in the BGP configuration submode, we can specify a neighbor by its IP address and its autonomous system number. The IP address has to be reachable. The router needs to have a valid route to that destination in its routing table. If it doesn't, it will remain stuck in the idle state and never move to the connect state. Let's have a demonstration. In this one, we want to peer between router 2 and router 1 on their G1 interface. So here we are on router 1. Let's check if we have IP reachability. Okay, looks like we have. Let's see if we have any BGP configuration yet. Okay, we don't, so let's configure BGP. This is autonomous system number 1. The neighbor IP address. And the neighbor remote autonomous system number is number 2. Let's do the same thing from router 2. Let's see if we have any BGP configuration. We don't, so let's configure BGP. This is router BGP autonomous system number 2. The important thing is that the autonomous system configured here needs to match with the one configured here. If I mismatch those two, I will never have the adjacency come up. So the neighbor IP address and the remote autonomous system, I will let you guess which should it be. It has to be the autonomous system number that I have configured here. So it is number 1. With this, the adjacency should come up now. Let's wait a bit. Okay, here it is. It just came up. And we can also see here. It came up 14 seconds ago. The command to verify the state of your BGP sessions is show IP BGP summary. There is another command that does exactly the same thing, but isn't limited to IPv4 unicast. With the second, you can specify an address family and subsequent address family. We have just seen how to configure BGP for directly connected peers. Now, instead of peering them on their physical interface, let's peer them on the loopbacks. The configuration is pretty much the same. We start by configuring the BGP process with the local autonomous system number, and then we configure the neighbor. This time, as the IP address, we'll specify the loopbacks of the remote router. Let's do this and see what happens. Let's get back to router 1 and delete the BGP configuration. Let's do the same thing on router 2. Let's check if we have IP reachability to the loopbacks. Okay, seems like we do. So let's configure BGP to peer on the loopbacks. Neighbor. So here I specify the loopback of router 2, and the remote AS is also number 2. So here router BGP 2, I specify the IP address of router 1, loopback IP address. Okay, here it is. What happens if I do show IP summary? IP BGP summary, sorry. It is in the idle state. Let's do a debug and see what happens. Okay, we can see that it is saying that the update source null is not available. What this message really means is that the router doesn't have a directly connected route to the destination. There are two important things about eBGP that I haven't told you yet. By default, eBGP requires a route to the peer that is directly connected. Not a static route, not an OSPF route, but a route that is directly connected with an administrative distance of 0. Also, eBGP packets have a time to live of 1. This means that the multi-hop ability is disabled by default. There is a third thing we need to talk about. This one concerns both eBGP and iBGP. If a router has only a default route to reach its peer destination address and no more specific route, in this case it won't initiate the TCP session. It will just remain in the active state waiting for the peer to initiate the session. If it receives a TCP request, it will respond and establish the TCP session. This was done this way to prevent instabilities. Back to the configuration. So to disable the default requirement to have a route that is directly connected, there is a command. We specify the neighbor IP address and we add the keyword disable connected check. So let's do that and see what happens next. Let's get back to our routers and disable the connected check requirement. Here it is for router 1. Let's do it for router 2 as well. Okay, here it is. Let's do a debug and see what happens. Okay, it says that there is no route to the peer. Remember that BGP doesn't initiate the TCP session if the only route it has is a default route. Let's see what we have. Show IP route. Here it is. To reach this IP address, our only route is the default one. So to make router 1 initiate the TCP session, let's configure a static route. Okay. Okay, here it is. We can see that the output is changing, but the session isn't coming up yet. So there must be a problem. Let's do a packet capture and try to see what is happening. So here is our capture between router 1 and router 2. We can see that router 1 is trying to initiate the TCP session. Here is the SYN flag. But it is initiating the TCP session with its physical IP address instead of its loopback. That's why router 2 is immediately closing the TCP session with an RST flag. So this brings us to our last command. It is the update source. Here we specify the interface to use to initiate the TCP session. Here we are back on router 1. Let's configure the interface to use to initiate the TCP session. So the keyword is update source. And then we specify the interface to use. In this case, it's loopback 0. Here it is. We should see the BGP session coming up soon. Okay, here it is. It just came up. If we get back to the packet capture, we can see that now router 1 is using its loopback to initiate the TCP session, and router 2 is using its loopback to respond as well. And here is the the BGP session coming up successfully. Here we are on router 2. It is worth noting that on router 2 we don't have the update source keyword used. It is automatically responding with its loopback. In this lesson, we have seen that we can control which router is initiating the TCP session. First, the one who had more than a default route will be initiating, while the one that has only a default route will just listen. Then, if we have two routers both trying to initiate, if one of them is using the wrong interface, it will get rejected. If one of the routers has the correct interface, you are guaranteed that he will be the one initiating the TCP session. There is also a command to control who's the initiator and who's the passive router. You specify a neighbor and then you add the keywords transport connection mode. Passive means that it will only wait for the other peer to initiate, and active means that it will be the initiator. Now, if we get back to router 1, we know that it is the one that has a more than a default route. It also has the correct interface, so he is the initiator. Now, if we make it the passive one, the the TCP session will never come up. So let's do that and see what happens. So let's make it passive. Let's bounce the BGP sessions. So now the session should never come back. Let's get back to Wireshark and see what happens there. If we get back to our packet capture, we can see here, this is where I have bounced the BGP session. Here router 1 is closing the TCP session with the fan flag. So from now on, router 1 will be passive and won't try to initiate. And router 2 won't as well, because it has only a default route, and if it gets a specific route, it also needs the correct interface. The important takeaways for this lesson. BGP has two types of peering sessions, external BGP and internal BGP. The behavior of BGP changes drastically depending on the type of the session. Unlike OSPF, for example, BGP can form a neighbor relationship with a router that is many hops away. eBGP by default requires that two neighbors to be directly connected. This is enforced by the direct check and a TTL of 1. BGP won't initiate a TCP session if the only route it has is a default route. Now that we have enough knowledge about BGP sessions, we can start our labs. After this lesson, you will find a series of labs. Please check them out.